Welcome to lesson number 5 of the Claw lessons featuring Diego. So before we get started, I just want to thank Scholars Portal again very much for hosting this. We couldn't do it without them. And of course, Diego. So what we're going to do today is we're going to do an overview of the microservices. So this might be a little bit of a departure for folks because we've been concentrating on the 7x 2x branch, like what we would refer to as the master branch right now. And this is we're going to highlight some work that's being done in what we call the dev branch, which is I think Sprint 002, if I remember correctly, or something like that. And that's where we're redoing all of the microservices in PHP in a framework called Silex. So what's going to happen today is Diego is going to kind of do an overview of some theory with microservices and introduce Silex. For folks that don't know what Silex is a micro framework. It's modern PHP. It's pretty great, and it's you could say it's like Symfony Light. So one thing that this really does for us is if you don't know, Drupal 8 is basically Symfony. So it's going to allow us to pivot to Drupal 8 much more easily. So that said, as always, I will, when I'm actually here, I'll be the moderator. So I'll keep an eye on the chat. And if you have questions or anything like that, or you need some clarification, just jump in there and I'll let Diego do his awesome thing. And if we need to interrupt him, I will use my voice and interrupt him.
Cool.
That said, I guess I'll just turn it over to you, Diego, and I will mute myself.
Thank you very much, Nick, for this very nice introduction. Well, people, we will start with something very new. As Nick said, in the last months we have been working building a parallel version of Claw, secret plan, and building these little tiny pieces of code named microservices that will help us in the near future to basically achieve two things. To get back to PHP, so we have more developers, more people involved, and also to split the work we are doing right now in the way we are interacting with Fedora 4. This first part, this first lesson, I will divide this in two ones, will be practically mostly theory. And I know it's very difficult to teach people how to program Symfony and Silex. We are all still learning the hard way. But at the end of this session, I think you will have like a very good notion of what this is, how it works, how this brings us to this millennium in PHP. And the next one will be a fully practical one where we will build together a service from scratch. And I have high hopes on that one because basically I think if we can move like all the development tasks to the community and make this simple framework work for us all, we'll have a Claw working version very soon. So I will start. Last time I said next session we'll write some CAMEL roads. I was lying. Why? Basically because I changed my mind. CAMEL is awesome. CAMEL has a great potential and it's very good for a lot of stuff that is done async. But the truth is we need PHP right now. And basically because we are very used to it, we know how to go to PHP, and there are some tasks that are better done as atomic individual operations than as a whole complex CAMEL workflow. So I will introduce you to these microservices in Claw. So this all started with a simple idea. Instead of having this very big complex chunk of working code like we had before named Tuke, this all-purpose code, specialist in all styles, we started building from scratch some very lightweight PHP services. And each of these PHP services was built to do a particular task, reusing code from other services we're building, and also external classes or even full packages. And so Nick and Danny started building Chullo. And Chullo is a different type of hat, and it has a very specific role. It passes messages to Fedora 4, and that's all what it does. And then we have these other little services that play well, that interact with Chullo, like the resource service. The resource service handles RDF, do some stuff with that, and pass it to Chullo. So these microservices are not only just PHP code and classes. These are services, real. What that means, they run at an HTTP URL and a port, and they're listening and processing what you send to them. So in this case, the resource service takes that HTTP post message, takes the bullet for Chullo, does all the pre-processing of that, takes the headers, all the things we saw on the Fedora 4 interaction using curl, and then reuses Chullo, invokes it with that message pre-processed. And basically the whole idea is like Chullo doesn't care about the resource service. And the resource service just knows that Chullo provides a class or some classes and interfaces to interact with that. This has some very nice benefits. First, we can really focus on making single parts of this whole CLO stack to work and be efficient. We don't have to make these interactions very complex. The second part is like we can swap little pieces of that. We can just use one service or use complex build service around integration of them. And we can even build a new Chullo and put it into the resource service injected. And that resource service will just know that it needs an interface of methods that it can call, but it doesn't have to care about Chullo. So, starting with this role separation, Chullo is where all started, and Chullo is not a service, it's a library. So you can go to GitHub under Cloud Chullo and see what's there. There's a little tutorial on how to make it work. You can work directly on Chullo without any service. And it reuses ECRDF and Guzzle. ECRDF is like a package of libraries and classes that allows us to mash up RDF, transform it, add predicates and stuff. And Guzzle is like a very intelligent async PSR7 compliant HTTP client. Basically, we can send something using Guzzle, we can receive stuff using Guzzle, using predefined, very well-defined protocols, and it's based on something named premise. So we don't have a promise, sorry. And with that promise, we don't have to wait to come back. So we just send something and we can do all async working on PHP, because PHP is not very good at async. So, and this Chullo has interfaces. Basically, it has these classes that extend these interfaces, so we can build new classes based on those common interfaces. And it provides some few very limited and very well done base classes. We have like this namespace. Who has this namespace? I will go into that further in the next slides. We have Islandora Chullo, which provides a Fedora API. This is a full API that allows us to put, get, and whatever we want stuff into Fedora. We have the Chullo class, which is a simplified version of this Fedora API. It does more pre-processing, so it's more smarter, but also less flexible. And we have the triple store client, which can ask stuff from our triple store, in this case, Blaze Graph, and parse those responses as a graph. using as ECRDF. And then we have also an additional library named Islandora UID namespace, and the class name is UID generator. And we use this to create UID version 4 and version 5 identifiers. Basically, we are going back in time, and we are, as we saw last time, we are using these UIDs to define, to match our Fedora 4 paths, and we have this little class that does the hard work for us. But before going further into each service and what they do, I want to talk about modern PHP. And when I'm talking about modern PHP, I'm talking about this millennium PHP, basically. Sadly, we are very used to a procedural way of building stuff on the older Islandora side, because Drupal 7 is all based on hooks, and hooks are pretty much functions, and we forget about how other languages deal with object-oriented programming. But PHP has evolved, and has evolved a lot. Recently, last year at the end, we had like this PHP 7 release, and in our minds we're still living in like PHP 5 dot something. So let's talk about this. Java people, you will be amazed how back we were before. Well, PHP can be really a modern object-oriented programming language. We have namespaces. So a very simple stock PHP program defines like a class named users, and then you have like your own application that defines a class users, and you want to use both classes, and PHP says no. Why? Because on the global scope we can have only one class named user. Well, since PHP 5.3 we have something named namespaces, and namespaces allows us to give each class or a group of classes a context. Basically, we can, using namespaces, have multiple user classes, each one inside a context, and that leads to a lot of benefits. There's a link, well, you can search on the PHPNet site, and there's a lot about that. So, trying to explain this in a simple way, we have this global namespace, or better said, the no namespace, always there. I have this little app named my app, stored in my app includes stuff.php, and this one defines a class named stuff. And then I have another file that makes a new instance of this and builds a new stuff named some stuff. Well, with namespaces, I get like this first declaration, namespace good, and then I define again class stuff. The good thing is I can, in another one, call this class using the namespace, and this d stuff is a new good \stuff. This is very interesting because all this stuff can convive together. Yeah, people at Java have that. But the good thing is we're going to use this for a lot of more stuff, and I will explain you this in the next slide. We also have this relativity concept. So if also now define again my namespace good and this class stuff, and then I have this new file named my app the real thing 2.php, and I again define namespace good, all the things I build there will be in that context. So if I call new stuff directly, I'm building really a good stuff object based on that class. And this relativity concept goes further. I have this, again, namespace good, and then I tell them create a new stuff. That one is still good new stuff. But if I use this backslash directly, new slash backslash stuff, I'm calling the global stuff class, the first one I created here. Okay, this sounds all very complex, but I will make it more complex even. I can also use like symlinks for this. I can tell Drupal to use good stuff as very good. And I can tell them that it should create a new very good instance of fine stuff. And that one is really a class in namespace good named stuff. And when I call again as stuff, new backslash stuff, I'm calling the main global namespace class. Basically, this allows us to have a full definition of our packages and our classes defined inside that. And these namespaces can be huge. Like there are some applications around, some apps, some packages that use a lot of sub namespaces. On our side, we have this Islandora. This is the base namespace, and it's good practice to make this the vendor or unique personal namespace. In our case, Islandora. And then we have the Chullo one, and we have the UID. If you look at this, we are not declaring here the name of the class. We're just telling that our new class will be in that namespace. Namespaces were used as part of the PIDs in Fedora 3, so we should have like a basic sense of what they are. But these namespaces can also help us to organize our classes. We can replicate this namespacing using also a similar folder structure when we store our files. Sadly, this is not Java. Well, not sadly, but Java has some very good stuff, and one of that is like this import good everything. I can import anything. In PHP, I have to tell it what I want to get. Exactly. Well, but we get some help here again because PHP is very modern. We have autoloading capabilities provided by external systems. Basically, one of the problems we have with these namespaces is even when we define them, PHP doesn't know where they are stored, the files. It doesn't have a clear notion that if we have like a namespace named Islandora to UID, we have the last one, the classes in a file, in a folder named UID somewhere. So we have to make use of require and include anyway. And when you have like this big chunk of multiple different libraries and packages and classes that you want to reuse, you have to make this require once or whatever you want to use for each one. And this is a pain. So how do we use these namespaces and also allow PHP to find the files where the classes are? Well, autoloading is our friend. And to this aid comes PS4R4, which is something very well defined in the standard, and I'll explain it further, and this friend, Composer. And Composer will be your friend for the eternity right now. It's a very nice piece of software. Well, what is Composer? Composer is basically a tool that allows us to manage all our PHP dependencies. So we can declare libraries that are needed for a project, and Composer will manage that. Can install, update, and check also that all versions that are needed by one package are present, don't conflict with others. To get it, there's basically two lines you have to run, like getting this installer, which is a PHP file run by PHP, and then move this far file to user local bin Composer, and you're ready. So you can make it global and call it from everywhere. So key facts about Composer is like it uses this PSR4 style loading. I will explain it. It's not complicated. It can manage versions and dependencies for these PHP packages, and the whole stuff on which your project depends is defined in one JSON file. And once you run this composer update or install, it gets all these dependencies and store them in a local file named vendor inside your project. And it also creates an autoload PHP file. This one takes care of loading all the required files that are needed, so you can just use your namespaces when you need them. And inside, if you look at an autoload PHP file, you will see again a lot of requires, includes, and require once files, but you can forget about that because it does the stuff you need for you. You can also keep track of what you're using. So if you publish something built with composer.json and everything related to that, people can make sure that when they deploy that application, they will use the exact versions they should. And finally, it's cool and simple. Well, after using it a few times, of course, because documentation is not that great, but there are a lot of good examples out there. And also, we already built that for you on the Claw side. This is a composer JSON. Well, it's a lot of data, but I'll go through this because I think you need to understand what this means. First of all, since this is JSON and plain JSON, the same rules for our type of JSONs apply. And we have like these keys and these values. The first thing is we gave this Chullo one a name, and that name is related to the namespace, if you see that. We have descriptions, we define what type of package this is. If you looked, I said Chullo is a library. Yes, it's a library. We can give some extra metadata where the homepage is support, and then we say on which our packages Chullo depends on. So we tell it that we need PHP 5.5 or better. That's that symbol. We tell it that we need Gosel HTTP Gosel from version 6.10 or any major version that matches. ACRDF, same, JSON-LD, same, and we also require for development, for testing, PHP unit. Yeah, Chullo has all the tests included, and Nick did a great work building them. And we also define a license. Some authors, Nick and Danny, and the Islandora Foundation, and finally the magic autoload part. Basically, we're telling that Chullo provides this namespace, and it should start looking at the source folder. So, what in the hell is PSR4? It's a very ugly name for something very simple. You can read more on the PHP fake.org site on that, but basically if we have like this class named Symfony Core Request. Request is the class, that's the namespace. It's the same we use when creating a new request object. We create a new Symfony Core request. And we have this namespace prefix, Symfony Core, that part, without the backslash. And we define that the base source path for our module is vendor Symfony Core. Then PSR4 will search at vendor Symfony Core request.php for the file that contains the request class. Same here goes for Chullo. So this resolves all the include, requires, and whatever we need for dealing with classes and external packages, and we can just start using namespaces and use statements to load all the things we define for a whole composer project. So much new stuff. I hope this is new stuff. If not, better so, because jumping into Silex will be a lot easier. So, the simple ideas of having small microservices required some new knowledge. And we made some quick review on multiple frameworks that are around and decided to go with Silex. Basically, Silex is a micro framework, as Nick said, that simplifies developing some type of tasks. Basically, everything that is related to dealing with HTTP. And since it's a slim, very slim microservice, it allows us to build also in a few statements one file apps if you want. So the whole idea is to not reinvent the wheel, to not build some complex functions that deal with catching and interacting with HTTP and decoding messages. We get what we need to do, our communication with Fedora for work on Silex. And since Chullo is not Silex, but Resource Service is, it can use our packages that are not Silex because it's still PHP. Well, you can go through the documentation. It's pretty simple to follow. It doesn't say everything. You have to research further. But on the next session, we'll go deeper on that. So, as I said, micro framework, one file app possible. It's very similar to what we're doing with CAMEL. That's the reason I've swapped these sessions. But it's written in PHP. And it has less stuff. That's the reason it's micro. It's built for handling HTTP requests. It can build responses. It can handle requests. It can build some piping system. And it's based on a larger framework named Symfony. So we can reuse Symfony packages, modules, and whatever if we need them. We don't have to load them all at a time. And since Drupal 8 is Symfony based, this makes sense because if we learn this, we can jump into Drupal 8 hopefully soon. So the idea is we have this event-based routing system. We can define these routes. Routes are URLs that are bound to a method like get, post, put, delete, purge, whatever you want. Each route has a controller that does the stuff. When invoked, controller is a big word for functionality that gets run when you invoke a route. These routes can have middleware that allows us to change what we get before invoking the controller. So we can make a chain of preprocessors that work on the message we're getting, and then we can also make a chain of post-processors. So it's like a piping system. We have these multiple routes. Each route can modify its data using this middleware and finally process it using this controller. And Silex handles all the HTTP protocol for us. It can fetch headers, bodies, files, multiparts, whatever you want. And lastly, and very important, and I will go maybe deeper at the end when we do a round of questions, it can manage something named lazy loading using a container system, and can use also dependency injection. Both new words maybe for some of you. Lazy loading means that I don't have to make an instance of a class, means a new object, if I'm not using it directly. I can define all these new objects, but they don't get called, they don't get initiated until I really need them. And dependency injection means I can pass one object inside another object and just let that object deal with the methods that it should know, the interface, but I can swap those objects basically. So I can make that one object doesn't have to know everything about another object. Imagine like a database. There's this whole class that defines how I should deal with MySQL. But that class has some very simple methods, define an interface that say query, commit, rollback. And another object, a forum, gets this object injected inside. But it doesn't have to know it's MySQL. It just needs these three methods, like get something query, commit, and rollback. And if someone wants to use another type of database, it just swaps these objects and injects. And injection can be chained. So at the end, each of these classes are very simple and do unique tasks. You don't have to deal with the complexities of others. So this is the simple Silex app we can build. And this is like a one-on-one on getting started. We have this file stored in source and it's named app.php. We use this Autoload PHP build by Composer. And then we say, let's create a new Silex application named app. And then we create a road. And this road, which is built on this application, uses the method get and is bound to this path hello, and this one is dynamic, the name. And it uses this function, which is the controller, to do something. Basically, it gets name, which gets auto-assigned using this dynamic stuff, and also uses, this is a dependency injection, the whole app. And I can then return something. Hello, app escape, one of the many small methods that help us to deal with something, like the escaping, name, and I return that. And at the end, I run this app run, and I'm ready. This app run is like a little loop. It's an infinite loop that waits for something to happen. And that builds a kernel and has a lot of event routines. Basically, once I get this started, it starts waiting for calls to app and try to match these URLs to different methods and can generate or read events that these controllers are throwing. It's a very simple way of doing stuff. It's very similar to what all languages are doing. And it's still PHP. If you want to build this same small code in plain PHP, it will be like 500 lines. So, some buzzwords I will explain here, a few simple stuff. Basically, what a road is. So, the Silex framework provides PHP methods for all matching HTTP ones. So we get like get, post, purge, etc. If you look here, I have like the same get one. I have this road one, which is a real URL, and this here the ID, which is dynamic one. I'm telling the function to use Silex application app. I'm type hinting here. This is also dependency injection. And I'm also telling it to use ID directly. But also I have another statement that allows me to use an external variable somewhere and make it local. And then I just make some checks. If this ID is Hydra, I tell him, hey, abort, this is Islandora. And abort is also a shortcut for building a whole response message that says, hey, this is an HTTP response with code 404, and also abort everything and pipe this out. And if not, I can return a found app escape ID. So these roads are matched using a pattern. This is the pattern. And it can be also have these dynamic parts. These roads are matched on priorities. So you have like if I have first a road 1, something else, and then I have this road 1, something else, the first one that matches will be invoked. This is very important when you build, like just try to build them in the order you want to be matched. And the use is like passing something to disclosure, and the return, in this case, in this context, is just a shortcut for giving an HTTP code 200 response with a body. That's the body. And as I said, the abort can shortcut everything. If we have like multiple posts and middleware somewhere with the abort, I'm cutting here, I'm returning that to the user. So let's use namespaces. We learned that, and we have composer running. This is a more interesting route. I have a post route, and this route is just this one URL is a receiver, and now I have a different type ending here because I'm getting a request. Basically, a post gets a request, and this request object comes from Symfony. So I'm telling here to the autoloader has all the dependencies there, and I'm just telling it to use Symfony component HTTP Foundation request as request directly. That's the reason we have this use statement. And then I also pass the whole app inside. Well, now I have to get what someone posted to me. This is the request object that contains the whole post request. And I tell him, hey, get that stuff variable inside that post. And then do something, but instead of just returning the, hey, thank you, I will build a new response. And a new response can have codes, headers, or whatever I want. So I'm telling here, return new response, gracias, got your stuff 201. And I make it run. Very simple. There are a lot of included components that we can use. Symfony is very well documented, and we can like look into the Symfony website and see what methods request and response have. And basically with this, we can make a whole system that listens for messages, parses them, modifies them, and sends them back to you in a very few simple steps. With few, I mean like 200 steps. With simple, I mean like learning 1, 2 weeks, 3 weeks this. At the same implementation in Tuke is huge, and this is very simple to manage. So the controller. The controller is basically this part. It's what's inside the function until the return. The controller is the worker. It does the processing, and it can be inline, as in the examples I showed you, or it can even be a class method, lazy loaded, so only called when the road is called, or even a service. And service I will explain you in the next session, because services inside Silex have a predefined interface and are more complex to build, but also more flexible. So this one is an example of a post road using a direct call to a class there and a method. Basically, I'm telling here to use the Islandora magic class and call fill repo. Would be nice if we had like something that we don't have. Middleware. Middleware are just ways of intercepting our request, the message vars or whatever we're getting from the user, and modifying it before and after passing it to the controller. We have like these base ones, the before, the after, and the finish. And some of these can be used globally, so directly on the app object. And others can be used only on the road itself. And they can be chained. Like I have this app post road, the same one, and my first middleware that runs before fill repo just dumps the door tree. And the next one converts that to RDF, and then magic fill repo gets called and does all the magic stuff. And after that, I have this method named take a rest, and it runs that. And we're done. We can reuse these middlewares we can define them globally, we can share them, we can also use here methods and classes or direct inline functions. It depends on our needs, on how pretty we want our code. And there's so much more about Silex. We could talk like, well, I could talk like a few days about it. But basically, what I want to explain is I don't want to replace CAMEL with Silex. And you can think like, hey, we had like these 4 sessions and you told me everything about CAMEL and how complex and fine it was, and then we have these services. No. The whole idea is to make some type of task that we need better in PHP, because PHP is a known language for a lot of you, and also some tasks don't require the whole piping complexism of CAMEL, but also rely on CAMEL for the async stuff. So, for example, we can send stuff directly from Drupal to a microservice that is running. And these microservices can run everywhere. They can run on the same server, another server, or we can have mount all services, microservices in one, or some in one server or another. We don't care. And these little services deal with that Drupal node, convert them to something. There are small wrappers around Fedora 4 and do their magic. And once something is inside Fedora 4, CAMEL comes in place again. And it's waiting for these messages, and it gets a new resource created message, and then it does its magic. It can even again call these microservices built in PHP, so we don't have to deal with RDF on Java. Some people like it, or other people don't. And it can sync back what we get from Fedora into Drupal. So one doesn't replace another. We just move some functionality to the Silex framework. It made us happier. Our code was simple to build, and it runs pretty fast. And CAMEL is still good for making sure that messages get past it. It can resend and re-ask for a message, and it deals with all the async. And so, show me the real code. I don't want to scare you with the real code really, but I will give you like a quick glimpse on that, under the notion that on the next session we'll build a real service that does some very particular stuff, and it's related to the whole this lesson class plan. Basically, I want you make part of building a better solution pack based on some stuff on Drupal, some stuff on Silex, and some stuff on CAMEL. And we will start on the simplest one and the newest one, which is Silex. So I will jump to live code if I still have time. I don't know. Oh yeah, I do have. So, can you see my screen? Shall I make it bigger? Okay. Well, I will first start showing you how the Fedora API
Diego?
file works. Yeah, sorry. Yeah.
Can you just paste the link to that in the little chat for everyone?
Yeah, sorry. I will make
Then people could jump and follow along.
Cool. You will get that one. You will get this cool one, just fresh built by Jared, and you will get this that is an example of how we started everything on the resource service and how it made some evolution. And I will also pass this one, which is very interesting for nerd people like me. Okay, let's start with Chullo. So basically we have this namespace Islandora Chullo, and we're using this Gosel HTTP client. We're using this PSR HTTP message response interface, which is the way we're dealing with our messages. And we're using also the component, the response component from Symfony. And if you look here closely, we have this class Fedora API that implements an interface. We have a common interface for the Chullo class and the Fedora API class. The difference is that some methods are more generic and other ones are more specific. Fedora API is the one we're using right now on our microservices in Silex. So I want to show you what we can do with this. Basically, if you look, they're very simple. It's like we have this construct that just gets a client and assigns it. We have this create that creates a new client with this Fedora REST URL and returns a new Gosel client. And we have these helper methods that allows us to get us base URL. Everything is very well explained there. We have this one that gets a Fedora resource, sets some headers, prepares an URI, and sends everything using the client. We can get the headers, we can get our options, we can create a resource. We're setting a body, a header, we can use this checksumming, we prepare, and we send. If someone of you had the luck or the bad luck to go into Tuke, that was much more difficult. Basically, not only because Tuke is more complex, but because also interacting with Fedora 3 is more complex. And Fedora 4 API is very well documented and very simple to interact with. And we have a lot of other different here methods, like we can save something, we can modify something, we can delete our resource, and we have this helper function to prepare URI that gets our base URI and trims some stuff and adds some slashes and explodes and basically returns the correct path. If you look, those mimic every car example we saw on the previous lesson. Like we have copy, delete, move, get, whatever. It has Fedora 4, we have it here, but in very simple PHP code. Going back here, that was the class. The interface, if you're not used to interfaces, interfaces are just a way of declaring a general view of how our classes will handle their methods. And a simple interface, not an abstract one, just defines what methods we will make available, and when we extend them, we use them and implement them. So we have the same. If you look, same ones. And also, Chullo, this is another class. Oh, internet. Implement something. So we have like this very simple set of classes and interfaces we can play with. The second link I passed it is something that Jared did this weekend, and it's very great. He took everything we have learned and the hard way during the last months about how to use this microservice we built. So it also integrated into the Sprint 2 branch, and you can check out different parts and how to install using the Vagrant machine. And it explains how we have like this configurations and the settings, and you can read it with some calm after this session. What I wanted to show you is how one of the services got started. This is one of our main services, the resource service, and we use it everywhere, basically. The resource service is a wrapper around the Fedora 4 REST API, but it does some extra stuff that is needed for Drupal to interact with Fedora, and some things we need on the Islandora side also. This one I'm showing you right now is how things got started. The new resource service is more complex because it basically moved everything that is in line into individual controller services. But this is a good example of how to get started. Basically, I have this new application, as in the demos. I have this one. This is a container configuration for the app that telling Silex that I go into the book mode. And then I can register these additional services. In this case, I'm registering one named Twig Service Provider. That is a templating system. And I'm passing some init stuff to get started. And there are different ways of using these initializations in Silex. I can share some initializations. I can make them static. I can make them load one and create only one instance for the whole run, or I can allow Silex to create new objects for the same class each time they're invoked. The lazy part is the coolest part. It's basically none of this app triple store, or the app API I'm using here. If you look at Fedora API create, this is from Chullo, or the triple store create, are used load into memory until I really have a use for it. And then we have this very simple YAML loader. We can define our config settings there. So we have this base config settings, and I can swap the debug settings and the main settings. And then I have like this function. This is very simple one. This is a middleware that handles browser requests. And what I do here is basically transform something made using a browser to a different type of request. So if I call one of the services using a browser, I transform it to a different request, so Fedora 4 doesn't spit back HTML. And each of these little functions, header, host header normalize, ID to URI, are middleware functions. And then I have this big main controller collection that has all these controllers, and I tell them, hey, apply all middleware that I have before to every controller. So each time I call a controller, it converts first that message using that ID URI. It then checks if the ID has that type of regex, and then before it gets to the controller, it normalizes our headers and then our host header. And then I have this app view, which basically says after you send stuff to the app and before it gets to the user, I want to transform my response to something different. And finally, here, one road. And that one is very simple. It's like Islandora resource, some ID, some child. And this function takes the whole application, injected there, a request, an ID and a child, gets the TX, the transaction information, gets all the metadata, if it's there, the FCR metadata, and tries to get a resource using the app API get resource. And that call is to Chullo, because app API is a container for a Chullo object. And since it's shared, it's called only once. And once it's there, it's one instance of an object that is reused by other routers also. So we're injecting here Chullo. And if something goes wrong, I get an exception. I say, hey, abort, Fedora 4 is not available, and I return the response. So this is very simple. It's like building roads, building a whole website, building a whole portal using Silex becomes basically building a well-coded controller, because all the details on how to handle the request, on how to fetch metadata, on how to fetch parameters, or to mash up our headers is built into Silex and their little helpers coming from Symfony. You can go through this and you can reuse this, because basically I left everything inside the code. I have the different get status codes, and you can test this and build something again. And after that, this is also very cool, we have all these error function interceptions that we can use. So I can have from the most generic ones to the more specific ones. If I get a general HTTP exception and I'm telling that, hey, this is the book, then just pass it away. If not, return this response, Islandora service exception. Okay, but if I get a not found, then I can pass something different. And if I get a very general, it's like the main exception, just an uncaptured exception, I don't know what it is. If you look, most of the function parameters are type hinted. And type hinting is very important in Silex. I can define which of these ones get called, because all their error based on what the main error handler on the Silex app is getting the type of object. Basically, is the object that comes into the error is of this type, we'll call this one. If it's this type, we'll call this one. We use it a lot. This will also get used for. Okay, thanks for being here. It's used for also matching. We can have the same roads with different type hinting, and depending on what we get inside, we call different controllers. And that is for the basic one. If you go to the same version on Islandora Claw, sorry, yeah, running out of time? Just a second.
I was just going to give you a heads up that we're 2 minutes to the top of the hour. I don't know if you want to keep on going because you're on a roll, or
no. I just want
if folks need.
No, I just want to show people the same. Yeah. I just want to show people the same resource service we have on the current branch, and you can look at this and make then the comparison between one and another. Basically, our services are now joined and more complex. And that's all I will show you right now. It's too much information for one day, I know. But the next time we'll make it very practical. I will build from startup a whole service. We'll install Composer, we will get our dependencies, and we will start using this to make some very cool Fedora 4 interactions. And thank you, Nick, because time flies. And that's all.